All right, for part B, we're going to be answering the same exact question, but now we're working with this shape. Okay, so our process is going to be the same, but our equations are going to look different. Okay, so we're still finding dimensions that give the greatest volume, but now with the cylindrical tube with the circular base. Okay, so our constraint essentially still looks the same. You still have L plus this equals 108. Remember, this described the perimeter when we were working with the rectangle. If my pencil wants to work, there we go, rectangle. But now we're not a rectangle anymore, we're a cylinder, so this is circular. So when working with a circular, perimeter is more well known as the circumference. Hopefully I spelled that right, because we're working with the circle. Okay, well, what's the circumference of a circle? That is 2 pi r. So our constraint is going to be L plus 2 pi r is equal to 108. So we will need this later, so we're going to keep this here for now. The equation to optimize is still volume, but our volume is going to look a little bit different. Again, volume is length with height. Let's do this. Let's call length h, because we usually consider like this guy the height of the cylinder. So we're gonna have volume equals height times length times width, right? That's an area. Area of a circle, pi r squared. Okay. You'll most likely have all the equations you need on the exam. I talked to Colin and he said he's going to provide those. However, this is something you should be able to figure out without having it memorized, but that's unimportant. All right, so now we have our two equations. Again, constraint is always equal to a number. This will always just be equal to a variable, because that's what we're trying to find the largest of. Okay, once we have our two equations, our goal is to set v prime equal to 0, but we don't have v prime yet. So we need to take the derivative. We need to derive v prime. But first, like I said, I want to avoid product rule or implicit, like, I don't want to do that. That's why we have the constraint. We're going to plug her into here. If my pencil wants to work again. Why is she malfunctioning? Okay. Jesus Christ. Okay. So we have L plus 2 pi r is 108. And volume is h pi r squared. Well, I guess this is our new h, because we called the length h. Okay, sorry, it's just alphabet soup. It doesn't matter what your variables are called, just be consistent. So my two dimensions are h and r. So again, just solve for the easier one. It looks like h is going to be easier to solve for. Again, I don't want to FOIL things out if I plug in for r squared. Okay, so let's do h is equal to 108 minus 2 pi r. This h is the same as this h, so we're going to make a substitution and say volume is 108 minus 2 pi r times pi r h, because again, this is just our height given radius. Okay? We haven't taken any derivative yet. All we've done so far is algebra. This is the hardest part. If you can get here, you're gonna be okay. Let's do one more step of algebra before we take the derivative, because again, I don't want to do product rule. I haven't eliminated that yet. Let's multiply this in and then use power rule. So if I multiply this in, I get 108 pi r squared minus 2 pi squared r cubed. Okay, remember, this is just a number. I can have pi squared. Don't think it's a variable. I know it's confusing because it looks like a variable, but it's just a number. Okay, now I'm ready to take the derivative of v with respect to r. Remember, this is not r. This is a number, okay? Okay, so let's just do power rule. Treating pi like a constant, because that's what it is. I'm going to get 216 pi r minus, if I multiply the 3 down, I'll have 3 times 2, so 6 pi squared r squared. I want to set this equal to 0 and solve for r. Let's see what these have in common. I see a pi, I see an r, and you know what? 6 does divide 216. That makes our life easier. So if I pull out a 2, a 6, a pi, and an r, I'm going to be left with 16 minus pi r, oh my gosh, equals 0. Okay, in the typical sense, we would have r equals 0, and then we would have 36 minus pi r equals 0, giving me r equals 36 over pi. Again, this makes no sense in our case, so we don't want to consider that. If you're only getting r equals 0 as a solution, there's a good chance you're wrong. Okay, let's verify that this is a maximum. So here, let's do this up here. Let's verify. It's going to ask you to do that on the test most likely, so just get in the habit of doing it. Okay, so I want to see what's happening to the volume when my radius is slightly bigger than this. Let's just do like this, doesn't matter. Okay, let's see what happens to our volume derivative to figure out what's happening on v. All right, if I plug these into my derivative, it looks like this is going to be positive here, negative here. So my volume was increasing as I reached the radius of 36 over pi, and then it decreased once I started getting bigger than that in the radius. So this is indeed max. Remember, the question said find the dimensions. The dimensions of a cylinder are r and h. We have r. What is h? Well, this is h, right? So h is going to be 108 minus 2 pi 36 over pi. This pi cancels here. You get h is 108 minus 72, which I believe is 36 if I've done my math correct. So our answer is r equals 36 over pi. Sorry, h equals 36.